I'm Johnny Sod, here for the Chemistry News Network, CNN. You've seen me in such fine quality chemistry educational videos such as, what does oxidation have to do with it? And Pax Romana, baby, it's all in the Roman numbers. Part 4. Okay, balancing formulas, except now we're going to take it to the next step. We're looking now at cations that have Roman numerals on them. So, with that, I think we're going to need to do a little bit of a review as far as what are the Roman numerals. That would be the first thing to look at. So, with that, let's take a look. Now for us here, these are the Roman numerals that you would need to know, that you would be able to recognize it. You may have learned it at an earlier age, don't know? So I'm giving you a crash course. This is 1, this is 2, this is 3, this is 4, this is 5. Now if you notice, you got an IV, you got a 1 before the 5, or 5 take away 1. That makes it 4. This isn't Common Core math, folks. It's not. 6, notice it's a 5 with an extra 1. 5 plus 1 is 6. And here, it's a 7. So that's what the Roman numerals look like, and that's exactly what they mean. Roman numerals were out there for a long time. Now, the numbers that you're seeing here, those are Arabic numerals, in case you are wondering. Now, the Romans never had the number concept of 0. That was what the Arab numeric system gave us. They gave us the 0. Apart from algebra, they gave us the 0 as well. And it's not true to say, well, they gave us nothing. It's like, oh, be quiet. Okay? Now, let's go back to our problems here. So here, oh, that's not the right one. Come on. Come on. There we go. Let's go for it. So let's go ahead. We have got gold 1. So gold is a +1. When you look at those Roman numerals, you will only find them in the cations because it's telling us what the charge is. Well, why is it that you have got these guys in different numbers? Well, the reality is when you look at this, you'll notice that you have a gold 1, you have a gold 3. You don't see gold anywhere else. So gold can exist as a +1 or a +3. When you look at something like manganese, manganese here is a +2. You have manganese here at a +3. A manganese here at +4. Okay, a manganese at +6. Now there is a manganese at +7. Well, why is that going on? You may remember I mentioned to you about metals that they have different personalities. Yep, got my fans out there. Actually, it's Mr. Wilson. So, anyways, let's take a look at it. Let's go back to problem solving here. This is not that complicated. It really isn't, because you already know it. Okay, so gold 1, you know it's Au with a +1. Chloride is basically the chlorine with a -1. Now remember, crisscross. The crisscross here, okay, we'll take the, just like that. Say, wait a sec, it was that easy? Yeah. Let's take a look at titanium. Now titanium is a +3. Okay? So, if I go with titanium 3, chloride. That sounds yummy. Okay, so I have a titanium 3 chloride. Now remember, this is a binary ionic compound. You have a metal, titanium, and a non-metal, the chlorine. Let me make sure you guys can actually see that. Okay, a little bit of adjustment there. So, what does that look like? Well, we got a Ti with a 3 plus. We have a Cl with a 1 minus. Okay? So we can have Ti and Cl. We have crossing over, so here we'll have 1 Ti, and we're going to have 3 chlorines, 3 chlorides. Now we know, according to the rules, you don't ever show a 1. It's unnecessary, so we'll have TiCl3, just like that. So with that, how in the world do we figure this one out? Well, you know that Ti it's a Ti3, so it's a plus 3. Here we got 3 times 1 minus for each one, so you got a plus 3, a minus 3, and that's going to equal 0, like that. That's balanced. So our final answer is TiCl3. Okay? That is the only difference that you have. Now, what if I gave you something where you had to identify what it was? If I gave you, let's take a look here. I got a, here's COCl3. What is that? Well, a couple of things. One, I know this has got to be a cation, so I know it's going to be positive, and I know that this is going to be negative. Now, when I look at it, I know that this is cobalt. The problem that I'm seeing with this is I don't know what kind of cobalt this is, because cobalt exists in different states. Okay, I take a look and I see a cobalt 3, a cobalt 2. So how in the world do I know which one is going to be which? What you look for is what's on this side. How many minuses do we have there? So I know it's a cobalt something. It's either 2 or 3. And I know it's a chloride. Now, what do I know about the chlorides? There's 3 of them. And each one, there's 3 of them. Each one has a -1 charge to it. So what does that mean? That means it's a -3 charge total. How many cobalts do we have? Well, according to this formula, we have 1. So my 1 has to equal a +3. If I only have 1 times x is equal to +3. Therefore, this has to be a cobalt 3 chloride. So that's what's going to happen. Cobalt 3 chloride, ladies and gentlemen. Yeah, not too bad. Now let's see if I can come up with another one that we work with. Okay. SB. Okay. Antimony 5-phosphide. So, antimony 5-phosphide. So, what is that going to look like? Well, I already got the name for it. So, let's see. What do I know? I know this has got to be positive, and here's the thing. What kind of positive? The clue is here. It's a 5, so it's SB with a 5+. Phosphide, I have a P with a 3-, like this. Ooh. Wait. I remember, Canu. You're going to crisscross this, aren't you? Oh yeah, we're going to crisscross it, all right. And it's going down because it's going to be that easy. Crisscross it. Okay, so I got SB3P5. Antimony 5-phosphide. Available at your local grocers. Not. Well, okay, let's check to see if it's legit. All right, well, each one of these is a +5, so 3 times a plus 5. That gets us a 15 plus. Here we have a 5 times a 3 minus, and that gets us a minus 15. So they cancel each other out, ladies and gentlemen, and that's it. So this is my balanced formula. Yeah. So, and with that, ladies and gentlemen, I can go ahead and work on one more. Let's take a quick look if I can find something here. Hey, I know this is going to be positive and this is going to be negative because remember my cat ions will always go to the left. Booyah. Okay? So what do I know? Well, I know that this is tin. I can look it up. It's tin, but I don't know what the charge is on the tin. Aha! But this is, in fact, an arsenide. Okay? Now, my arsenide has a -3 charge to it. So I know that this is a -3 charge. Now, if that's a -3 charge, and I got 2 of these, -3 times 2 is -6. And here I have a +3. Here I have 3 of these. What's my final charge on the thing? Well, if -3 times 2 is equal to 3 times x. And what's my x going to be? You solve for x. X is 2. So guess what? It is 10(2) arsenide. Yup. That's exactly what it is. Alrighty then. Well, I'm going to stop here, ladies and gentlemen, because that's about it. I think we pretty much covered naming binary ionic compounds. Hey, I hope this video has benefited you, and of course, like all the other YouTubers out there, feel free to like and click to subscribe. Hit that bell, you know you want to!